Okay guys, so today we're doing parallel lines, and parallel lines, they're basically, we've got to understand firstly what a parallel line is. Okay, and I know that there's a lot of writing here at the moment, I'm trying to get through the writing to see you, but firstly let's go over what they actually are. So parallel lines are basically two lines that are straight and they run parallel to each other. So this all means next to each other, okay? And what it means is that they're never going to run to a point where they cross over each other or get further apart. They're always going to run at the same angle so that they're straight. So a lot like railroad tracks, okay? If we have a look at these ones here, usually basically when you're reading a book or when you're looking in your maths textbook, you can tell they're parallel lines because they'll have these little markers on them, okay? These little arrows. So they will signify that they are parallel lines and they're never going to cross over or get further apart. Now, when we cut parallel lines with a straight line, we call that line the transversal, okay? So that's the transversal. And the transversal is a really important line because basically what happens when we cut parallel lines with the transversal, it creates these special angles for us. And these angles here are really important because what they actually do is they allow us to find other angles within our shape here, okay? Without using a protractor and without measuring, okay? We can just work it out, okay? So let's start with the first lot of special angles that it creates, and they're called corresponding angles, okay? And corresponding angles, they have a few features that are significant to them, okay? And they define them. So they sit on the same side of the transversal. So you'll see that these two angles here sit on the top side of the transversal, okay? So they're on the same side of the transversal. Corresponding angles are always equal. So that means that if this angle here equaled, let's say 95 degrees, this angle here would also equal 95 degrees. And you would note that if I knew the angle of that angle, this one here, I would be able to find the angle of this one here because they sit on a straight line, and on a straight line we have 180 degrees, okay? So if this one here was 95, it would mean that this one here was 85, okay? So this one here, let's say it's 95 degrees, which also means that that one there is 95 degrees. Now, that doesn't mean that these are the only corresponding angles in this shape, okay? They're not the only corresponding angles in this shape. We would also have corresponding angles here and here, okay? We would have them on the other side of the transversal. This angle here would be corresponding to this angle, okay? And this one here would be corresponding to that angle, okay? Just grab this pen. So they're corresponding angles, all right? They're equal, they look the same, okay? So if you look at these two pink ones here, they do look the same, that angle there and that angle there. And they're on the same side of the transversal. They are not, however, inside the parallel lines. So you've got one on the inside of the parallel lines and you've got one on the outside. Let's come down to alternate angles. Now, alternate angles are pretty easy to identify, I think, because if we look at these two, they both sit on the same side of the transversal, okay? Whereas alternate angles sit on the opposite sides of the transversal. So we've got one on this side of the transversal and one on that side of the transversal, excuse me. And they sit inside the parallel lines. So unlike our corresponding angle where we had one on the outside and one on the inside, here we have both of them on the inside of those parallel lines and on opposite sides of the transversal. They are equal, okay? They're equal angles. Which means that let's just say this angle here is, let's go with 70 degrees. It means that this angle here would also be 70 degrees. And as soon as I do that and as soon as I find that out, then I could potentially find this angle over here because it's a supplementary angle to this one, okay? They add up to 180 degrees. I could find this one here as well because they also sit on a straight line, okay? I could find this one here because it's vertically opposite to this 70 degrees. So as soon as you start to find some of these angles, it becomes very easy to find all of the angles in the shape itself, okay? Jumping down to co-interior angles. Now, co-interior angles, I always think of co-interior like co means two. If you've got co-captains, you've got two captains. And interior, if you've got the interior, if you're an interior designer, you design the inside of something. So there are two angles on the inside. And the inside in this instance is the parallel lines. Okay, you just need to remember that they sit on the same side of the transversal. Okay, so they've got their own little box in here. Okay, and they add to 180 degrees, which means that if we know the size of one, and let's just say that that's 80 degrees, okay, it means we can find the size of the other one because we just do 180 take away 80, okay, in this instance. So it would be 100 degrees, okay? So co-interior angles sit inside the parallel lines and on the same side of the transversal, and they add up to 180 degrees. It's the only one out of the three where they're not equal, okay? And I did mention vertically opposite angles, okay, before, and they are also equal as well, okay? So that's our first look at parallel lines. And what we're going to do in our next lesson is we're going to find some angles to do with parallel lines, and we're going to see if we can work out some measurements. All right, got any questions? Make sure you ask.